Welcome to the Geometry Semester 2 Exam Review Answer Key Explanation video. So to accompany the video, I will post a PDF version of this answer key in Google Classroom as well for you to go through. In this video, I may not go through every problem step by step because if some are repeat concepts of previous, I may just summarize the idea behind them. So right away, let's look at Chapter 6 and using the diagram and the given information to find the unknown length. So in both problems 1 and 2, they give us the given proportions. So you simply have to look at the images and take the side lengths. For example, in 1, BD over DA, so 20 over 8, equals BE over EC, which would be our unknown. So I labeled that X over 6. Then to solve any proportion, cross multiply. So 20 times 6 is 120, equals 8 times X. 120 divided by 8 will give us x, which is 15. So number 2 is the exact same concept, just using the values in this proportion. 24 over x equals 28 over 21. Cross multiply 21 times 24, divide by 28. Or you could simplify the 28 over 21 to 4 over 3. So then 3 times 24 divided by 4. Either way, we get the same answer of x equaling 18. Then, moving on to our next section, determining if triangles are similar, and then explain how you know that they are, if they are, and state the similarity statement. So if we look at example 3, we know in these triangles, angle A is congruent to angle G, B is congruent to F, and C is congruent to H. We know that because the total angle measure in any triangle is 180. So if we have a 50, a 90, that leaves angle A to be 40. And then GHF, a 40 and a 90, leaves angle F to be 50. So we know we have 3 congruent angles, meaning we have angle, 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 similarity. So triangle ABC is similar to triangle GFH. In 4, we can find our missing angles. We know vertical angles are congruent, so these are both 42. We have the 95 here, so our missing angle was 43. 42 and 46 gives us a missing angle of 92. So we do not have any sides marked, only one set of congruent angles, so these are not similar. 5, we can check the side ratios for side, side, side similarity. If all 3 ratios are equal of corresponding parts, then they're similar. In this case, 8 over 12, 4 over 8, and 12 over 16, the proportions of the corresponding parts, are not equivalent, so these are not similar. And then in 6, we have the vertical angles here that are congruent. So angle DHG and angle FHE are congruent. And then we can check our side ratios. So 15 over 36 equals 10 over 24. So we have side angle side similarity. Now in the next section, we will be setting up the proportions with corresponding pieces. So in this case, x minus 4 over 9 would equal x over 12, matching up our corresponding pieces. Then cross multiply 12 times x minus 4 is 12x minus 36 equals 9x. So then we can subtract the 12x, negative 3x equals negative 36, x equals 12. In the next one, 6 over 16 equals 9 over x. Cross multiply and divide, x is 24. In number 9, our corresponding parts would be the 50 and the 35, and then the 40 and the x. We know that because of the parallel segments here. So then the 50 over 35 equals 40 over x. Cross multiply and divide to solve, and x equals 28. And then in number 10, again, using the parallel lines to find our matching corresponding pieces. So the 19.5 over x equals 18 over 24. Cross multiply and divide, and x equals 26. Then in 11 and 12, we're dealing with dilations or scale size changes. So given the scale factor of k, to find our new coordinates, we would take our original coordinates and multiply both the x and y values by the scale factor k. So negative 1, 1 times 3 gives us a prime, and so on for our other 2 points. And then you can graph both triangles, the original ACB right here, and then our final image, A prime, C prime, B prime, right there. And then in 12, it says the dilation from A to B. First, we're stating if it's a reduction or an enlargement. So A is our outer figure, B is our inner. Obviously, from A to B, it got smaller, so it was a reduction. Then find the scale factor. So the easy way to do that is pick one point off of B, the corresponding point off of A. So I have negative 3, 3, negative 1, 1. And I want to think, how did I go from negative 3, 3 to negative 1, 1? What would that have been multiplied by? And in this case, both were divided by 3, which is the same as multiplying by 1/3. So our scale factor of k was 1/3. Chapter 7, first looking at Pythagorean theorem, which again is legs squared plus the other leg squared equals hypotenuse squared, or simple terms, a squared plus b squared equals c squared. So you want to remember the legs are the two sides that meet at 90 degrees. Hypotenuse is the side opposite the 90-degree angle. So just applying Pythagorean theorem to numbers 1, 2, and 3. We'll go through number 1 here. Leg squared plus leg squared equals hypotenuse squared. 28 squared plus 45 squared is x squared. Add those two, which is 2,809, equals x squared, square root, to get the value of x, which is 53. Now, number 2, we're looking for a leg, so it would be x squared plus the other leg, 64 squared, equals 80 squared, 2,304, when we do the 80 squared minus 64 squared. That equals x squared, square root that, and x is 48. And 3, x squared plus 56 squared equals 106 squared. So we would do 106 squared minus 56 squared. That equals x squared, so 8,100. Square root both sides, and x equals 90. Tell whether the given lengths represent an acute, obtuse, or right triangle. Show the work. So you want to take the two smaller sides and check if those two sides squared equal the third larger side squared. If they end up being equal, it is a right triangle. If the two smaller sides added together are greater than the third side, then it's acute. And if that third side would be greater than the two smaller sides, it would be obtuse. So setting those up and checking, in 4 we have right, in 5 we have acute, and in 6 we have right. 7 and 8 did not print properly, but if they did, here would be our measurements. So we'd have side SR of 7, RT of 9, and RU of X. We would set up proportions again. So it'd be X over 7. They share this altitude, equals 9 over X. Cross multiply, so 63 equals X squared. So X would equal the square root of 63. In 8, it would be the similar thing if we knew ED was 10 and DF was 4 and DG was X. We would set that up as X over 10 equals 4 over X. So then 40 equals X squared, and X is the square root of 40. In 9, 10, and 11, we're using our rules for our special right triangles. So in 9, we have a 45, 45, 90, where we know the two legs are the same, and the hypotenuse is the leg multiplied by the square root of 2. So X is simply 10 square root 2. In 10, we have a 30, 60, 90 triangle. We have the 60 degree, 90 degree angle, meaning that's 30. And in a 30, 60, 90, we know the longer leg is the short leg times the square root of 3. So if we divide by the square root of 3, we get our shorter leg x, which is 8. Then the hypotenuse is the shorter leg times 2, so y would be 16. And then in 11, we have a 45, 45, 90 again. So we know x and y are the same. So we would take square root of 10 divided by square root of 2, simplify that, so multiply top and bottom by the square root of 2, giving us square root of 20 over 2. Square root of 20 simplifies to the square root of 4, which is 2, so that cancels, leaving us with the square root of 5 for x and y. Moving down to 12, 13, 14, we're looking at sine, cosine, tangent. So in 12, we would have a tangent scenario because we have the 38 degrees here, and we're looking at the side opposite and adjacent. So tangent is always opposite over adjacent. So tangent of 38 is 4 over x. So to solve for x, it would be 4 divided by the tangent of 38, which is approximately 5.1. 13, we have the 49 degree angle. We have the opposite and the hypotenuse, so we'll be using sine. Sine of 49 equals x over 15. So 15 multiplied by sine of 49 is x, 11.3. 70 degree angle. We have the side adjacent and the hypotenuse. So adjacent and hypotenuse is cosine. Cosine of 70 equals x over 14. 14 times the cosine of 70 is x, which would be approximately 4.8. Now to solve the right triangle, show all your work round to the nearest tenth. I have all the work laid out here. I'll let you work through those, and then if you have questions on those setups and how I came up with those parts, let me know. Otherwise, they're laid out step by step for you based on the ideas that triangle angles add up to 180. And because they're right triangles, we would use sine, cosine, and tangent to find missing lengths or angles. Now in 17, what you'd want to do is take the word problem. We know the shadow was 20 feet, and we knew the angle measure with the shadow and the top of the telephone pole, so this angle here, was 70 degrees. So 20 feet, 70 degrees. So then in this case, we're looking for the height of the pole, so we could use tangent of 70 equals x over 20. So 20 times tangent of 70 is x, giving us the height of the pole to be approximately 55 feet. Chapter 8. The key to these first few problems is this formula, n minus 2 in parentheses times 180. N being our number of sides. So to find our total angle measure, we'd take number of sides minus 2 times 180. So decagon, 10 minus 2 times 180. And then a hexagon, 6 minus 2 in parentheses times 180, giving us our angle totals. Then in 3 and 4, they gave us the angle totals. So we would set up the equation. Angle total equals n minus 2, then times 180. Divide by 180 and add 2 to get n. So in 3 we have 8 sides. And in 4 we have 16 sides, meaning a 16gon. In 8 we could call it an 8gon or the special name octagon. In number 5, because we have a hexagon, we know the angle total is 720 degrees. We add up the angles we know, which is 612. So 720 minus 612 gives us our missing angle of 108 degrees. In 6, we're looking at our exterior angles. We know the total's 360. We know the 96, 98 here. And we also know this exterior would be 90. So that gives us 284. So 360 minus 284 gives us our missing angle at 76 degrees. Then 7, 8, and 9, using some of our properties of parallelograms. In 7, we know diagonals are bisecting each other. So the x plus 6 would equal 2x plus 5. Solve that, and x equals 1. In 8, we know opposite sides are congruent, so y equals 9, x minus 4 equals 12, so x would equal 16. And then in 9, 4x equals 116, so x would equal 29, and we know adjacent angles equal 180, or our supplementary, so 180 minus 116 will give us y, so y is 64. Classify the quadrilaterals, then find x and y. So in 10 we have a rhombus, 11 a rectangle. So because it's a rhombus, opposite sides are equal, and all sides are equal. So 2y equals y plus 5. So solve for y, which would be 5. Then we know adjacent angles are supplementary again. So 180 minus the 100 will give us x. X is 80. Rectangle, opposite sides are equal. So 2y plus 1 equals 4y minus 5. And x plus 14 equals 3x plus 2. Solve for x, which would be 6. Solve for y, which would be 3. Finding the missing parts of the quadrilateral. 12, we're looking for a mid-segment. So mid-segment formula is 1/2 the measure of the two ends added together. So 25 plus 15 is 40, multiplied by 1/2 gives us the mid-segment of 20. 13, angle B. We know angle B and angle C, because it's an isosceles trapezoid, add to be 180. So then 180 minus angle C, which is 60, gives us angle B of 120. And then in number 14, we have a kite. So we know angle M and angle K are equal. So then 360 total of all four angles minus the 190 we already know will equal our 2x, or our missing angles. So 170 equals 2x, meaning each of those missing angles is 85 degrees. 15, 16, 17, most specific name of the quadrilateral. In 15, we know opposite sides are all congruent, 4 congruent sides. Rhombus. 16, opposite sides are parallel, parallelogram. 17, 4 right angles. Quadrilateral, opposite sides are parallel, rectangle. Chapter 9, Going into the vertices of triangle ABC. So first on both, I just graphed triangle ABC at negative 1, 1, 1, 3, and 2, negative 1. So triangle ABC here, triangle ABC here. Then graph the image using prime notation. So I graphed the pre-image first, then the image. So looking at this notation, x plus 2 means right 2, y minus 3, down 3. So I took each point, moved them right 2, down 3 to get my image. And in this one, the x value is a negative 1, so it's left 1, y value positive 1, up 1. So we took our original, moved each point left 1, up 1, and there's our final image. 3 and 4, they tell us that JKL is the original, J prime, K prime, L prime is the final image. Write the rule for the translation. So in 3, we went left 3, up 2. So we could write that in the kind of arrowed parentheses, negative 3 comma 2, or x minus 3 comma y plus 2. Then in 4, it went right 1 and down 2. So that would be 1 comma negative 2 in the arrowed parentheses, or x plus 1, y minus 2. And then we get to our reflection problems. So graphing the reflection over the x-axis, so we would just move each point the same distance on the opposite side of the x-axis, giving us triangle A prime, B prime, C prime right here. And in 6, reflecting over y equals x. So you could use the rules from your lesson to find our new coordinates, which would give us A prime, B prime, C prime, D prime right here. 7 and 8 tells us to rotate the figures. Lists the coordinates of the vertices of the image. So a 90-degree rotation means our coordinates xy become negative yx. So A prime, B prime, C prime listed here. And then a 180-degree rotation, xy becomes negative x, negative y, or opposite x, opposite of y. So listed here, s prime, t prime, u prime, v prime, with the figure graphed here. And in 7, you can see the graph of the triangle here. Then we get into symmetry, deciding if they have lines of symmetry and rotational symmetry. So in 9, we have one line of symmetry, no rotational symmetry, because the only way that figure looks the same is rotating at 360 degrees. In 10, we have 4 lines of symmetry and 90-degree rotational symmetry, because each 90 degrees we turn this figure, it looks the same. And then in 11, we have 2 lines of symmetry and 180-degree rotation symmetry, because if we rotate this 180 degrees, it would look identical. Then we get to our final problem 12, where we first have to dilate the triangle PQR, then reflect it. So first I graphed PQR. The dilation with the scale factor 1/3 means I want to multiply P, Q, and R's original coordinates by 1/3, or divide each by 3. So P prime, Q prime, R prime are at negative 2, 1, negative 1, 2, negative 1, 0. Then we need to take that figure, so that small triangle right here, and reflect it over the line x equals 1. So we'd have the vertical line here to reflect it over. So reflect it here, giving us P double prime at 4, 1, Q double prime at 3, 2, and R double prime at 3, 0. So if you have any questions after you go through the PDF in this video on the review, please make sure to ask them before your final day.